This is the PowerJack 150 watt 12 volt DC to 110 volt AC modified sine wave inverter. Now it currently is the smallest inverter that PowerJack has to offer, and really it is designed for compact mobile power using nothing more than the 12 volt adapter from your car. So, does this inverter stand up to the claims that PowerJack has made? Let's find out in this full video review of this PowerJack 150 watt modified sine wave inverter. Well, hey everyone, how's it going? And thanks for joining me. So I'm going to be doing a full in-depth review, a full test of this 150 watt unit. So before I get started, I want to go ahead and remind you to check out my Facebook page at GP Vlogs, where I'll have more pictures, notes, test notes, and a whole bunch of other stuff regarding this inverter as well as other inverters that I plan to review. So check that out, and of course subscribe if you want to see more of these videos. So this little 150 watt inverter is actually marketed as being mobile AC power. It is as simple as plugging the inverter into your 12 volt power adapter or cigarette lighter, and the inverter will output 110 volts AC. Now these types of inverters are actually very common. You can pick them up anywhere. They're relatively cheap. You can get them at eBay, Amazon, even some of your local stores will carry them. So let's go ahead and take a look at the specs from PowerJack on this particular inverter. So I'm only going to go over a few of these, but you can see that the inverter actually has a continuous rating of 120 watts, which means that you can draw that much current forever and it will not damage or overheat the unit. Now the max power output is usually read as surge load, but in this particular case it actually may be a temporary draw number in which the inverter can be loaded down to 150 watts for so many seconds or minutes before it shuts down or becomes damaged. Now it does produce a modified sine wave. It does output 60 Hz for the North American market, and it has a no load draw of 0.7 amps. So let's take a closer look at the inverter itself. On the front here you have the PowerJack sticker. On the back here you have the cooling fan right here in the middle. On the top is the 12 volt male connector. This actually connects to or plugs into your 12 volt vehicle adapter. On the bottom here you have a single universal AC output or outlet. You also have a 5 volt USB connection right here. And then you have a green status LED light. I do prefer that inverters like this have one of these corded type male connectors, because not all vehicles have a lot of room to be able to plug something like this into your adapter. You can see here that in my 2008 Pontiac Grand Prix, the inverter protrudes out of the gear selector area. My other option is inside the center console, but that wouldn't work either because there's not enough ventilation for the unit to run. Then when you add something on the end of this AC plug, it's just not going to work. So it may not work in all cases, which is again why I prefer to have something like this. But again, this unit is small enough and compact where it should work with most vehicles, and you shouldn't run into any kind of problem. Let's take a look at the equipment I will be using to test this inverter. For DC input, I'm using a 13 volt, 30 amp AC to DC converter. It is currently set at 13.8 volts. I'm using a kilowatt meter to monitor the load on the inverter itself, a clamp-on ammeter, which will show the load on the AC to DC converter. I am also using this EM125 handheld digital oscilloscope. I'm also going to be using this weird contraption here. It's something that I custom made. It's not quite finished yet, as you can see here, but this is my load tester. It can actually hold up to 10 bulbs here, and basically what it does is I have switches in the front here that control the individual bulbs. Again, it's not completely finished, but it's enough for this test here. Be able to control 10 individual bulbs and be able to load it down. I currently have a 100 watt bulb, a 10 watt bulb set up here, and then I also have some other bulbs that I can use that will increase the draw. Okay, so we're going to go ahead and power the unit up. Again, this would be the same as plugging it into your 12 volt adapter. And there is a fan in there that comes on automatically. It doesn't seem to matter whether there is a load or not. The fan does spin continuous. I will note that in a previous test, it took about 30 seconds from a cold start for the fan to spin up at its highest speed. Now I'll go ahead and bring my microphone in closer so that you can actually hear how loud the fan is. It's actually not that loud and definitely won't be noticeable when you are driving. The only time you'll ever hear it is likely if the car is off. Okay, so we can go ahead and look at the no load draw. Now PowerJack claims that this inverter draws 0.7 amps at 12 volts. This particular inverter is running at 13.8 volts, so there will be some difference there. The higher the voltage, the lower the amperage. So you can see here that at 13.8 volts, I'm actually drawing 0.23, maybe 0.24 amps approximately. Okay, so a note about the no load draw. This is one of those things that there is no on-off switch on the inverter itself. So if it's plugged in, it's running. You turn your car off, it's still running. Now you could probably get away, if you don't have anything plugged into it, you could probably get away with having it run overnight. You'll still be able to start your car, but depending on the strength of your battery, how old it is, etc., you may actually run into a no start situation, especially when you're under load. This is one of those things where if you've loaded this thing down all the way to its 150 watt maximum, I highly recommend you start your vehicle about every 15 minutes or so. This is one of those things where it's great for traveling when you're on the road, when you're on the highway, because then you don't have to worry about your battery going dead. You will have to unplug this unit before you leave your vehicle because it will continue to run. Now let's talk about the actual output voltage of this unit. So you can see here that under no load, it's actually putting out 137 volts. That's way too high for most items to be able to take. Now, laptops, anything with an AC adapter, usually will be able to do what's called a double mode, where it can use a 120 volt input as well as a 240 volt input. So it's a good chance that you'll be okay with this kind of voltage, but if it's something that's more sensitive to voltage, this may actually be a problem if it's a very low load item such as a charger. Now, as you can see here by this graph, you can see that when there's no load, you're running close to 140 volts. As the load increases, then the voltage does in fact drop here. I'm going to go ahead and put a load of 100 watts on this unit, and you'll see that the voltage actually does drop. But at 100 watts, you can see here that it's running at about 125 volts. Let's go ahead and add another 20 watts to the load, and as you can see, it's actually starting to come down a little bit more. Now, I did do this exact same test at a constant voltage of 12.5 volts. As you can see here, the voltage is significantly less. You can see here that at 100% load at 12.5 volts, it actually does drop down to an AC voltage of 100 volts, which I consider to be a little bit too low. But it peaks out at 116 volts and it settles in at about 104 volts with about a 50% load. Okay, so what does this all mean? Well, there does seem to be a sweet spot in which you want your voltage to be in order to get the best output voltage between 115 to 125 volts. Now, unfortunately, we have no way to actually change the voltage in our vehicles, or at least most vehicles don't have that ability. It's whatever the computer says that it actually needs to be at. So it's not an option for us to be able to actually tweak and find the sweet spot in our vehicles. Now, I will note that PowerJack does in fact advertise this as having an output voltage between 100 and 120 volts. That is actually correct, because when you get down into the mid to low 12 volt range, which is what this is advertised as, you in fact do get between 100 and 120 volts. So for frequency, it seems to be pretty consistent, right around 60 hertz. If I give it a load of 10 watts, you can see it doesn't change at all. Let's give it another 100 watts here, and you can see it drops for just a little bit, but it does pick it up, and we're right back where we started. We got about 110 watts on the unit. Through my testing, even at maximum draw, it still stays right around 60 hertz. Alright, so now let's go ahead and take a look at the waveform that this is producing. We'll go ahead and turn the unit on here. And as you can see here, it's kind of a dirty modified sine wave. Let's go ahead and put a 20 watt load on it. So with a 20 watt load, you can see that the wave actually does look more like a modified sine wave now. It actually looks exactly like a modified sine wave. I'm going to add another 100 watts. And as you can see there, the sine wave actually does stay the same. So this really is a modified sine wave. So what exactly does all of this mean with the modified sine waves and whatnot? Well, the power that's coming out of your electrical socket, which you actually plug into the wall, produces a 60 hertz pure sine wave. You've got a waveform that's nice and smooth. There's no flat spots, there's no pits, there's no jagged edges. That's the waveform that is considered to be the best, and the most expensive inverters out there produce a pure sine wave. You want it to be as close to the wall socket as you can possibly get. So what are the differences? I mean, what's it going to affect if you plug something into a modified sine wave inverter? Well, first of all, a lot of AC motors such as box fans, refrigerators, air conditioners, anything that has a compressor or a pump of some kind is going to run really hot if it's running on something like a modified sine wave. Now obviously this little unit here isn't going to be starting a refrigerator, but the point I'm trying to make is that you want, if you're looking for something that is going to be reliable, you're going to want something that's going to be a pure sine wave. So when you're shopping for an inverter, you want to make sure that if it's going to be critical appliances, such as a refrigerator or even a box fan, you might not think that of being critical, but if it is a box fan, it's got an AC motor in there. You're going to want to have a pure sine wave. That's what you want. Now, something like this, producing a modified sine wave, this would be great for something like plugging your laptops in. Light bulbs obviously run just fine on them. Small things like that, that's not going to be an issue. Alright, so now let's talk about efficiency. Efficiency is how well the inverter can convert the DC amperage into AC amperage. Looking at it in wattage, if you have 1 watt going in and 1 watt going out exactly, then it's a 1-to-1 and it's considered to be 100% efficient. Now, there are no inverters out there that are 100% efficient. There's always going to be losses in that conversion, usually due to heat. Some of the best inverters out there are between 92 and 95% efficient, but typically a really good inverter will be around 90% efficient. So if you have a 100 watt draw on the AC side, it's costing you 110 watts from the DC side or your battery bank in order to produce that 100 watts. The greater the efficiency, the lower the losses, and the longer you can actually run whatever it is you're running on battery. Now, PowerJack claims that this inverter has at least an 87% efficiency rating, but efficiency is usually affected by the total load. Most inverters are at their least efficient when they're not having any load on them. There is a sweet spot in every inverter where it is considered to be the most efficient or at its peak efficiency. So if we look at this chart here, we can see that when the inverter is on a very low load of about 10 watts, the efficiency is about 75%. Any load above 20 watts seems to increase the efficiency all the way up to about 93%. Now I did notice that there was a slight dip around 30 watts, but after 70 watts it seems to peak out around 92, 91 watts, right around that area. And at its lowest point, when it's fully loaded down, you're looking at about 89% efficiency. So what this means is that with this particular inverter, unless you're running a very low draw, such as a cell phone charger or even a laptop charger, your efficiency is going to be very high. It's going to be right around 90% on average. It is, in fact, a greater efficiency when under load than PowerJack claims. Of course, they claim that it has a greater than 87% efficiency. So they are right in that as long as you have the inverter loaded down at least 30 watts. All right, so I did mention that there was a sudden drop in output when you're loading down the inverter. So I'm going to show you, for example, I have a 100-watt light bulb right here in the very front. I'm going to go ahead and turn that on right now. For about a second, the inverter actually went down to about 40 volts, then came right back up. Now, I'm going to do that same test with just a 10-watt light bulb here, and it runs just fine. So what I found is that at about 50 watts, the inverter the voltage drops for about a second, then picks back up and seems to run just fine. In fact, the inverter has absolutely no problems then thereafter. Once you get that initial load down, there seems to be no problem after that with anything that it's going to be running. So is that really going to be a problem? No. Again, you're not going to be running a refrigerator on this. You might see a small drop for just a second on whatever the load is, but it does bring it back up. Again, this inverter is not intended to run any critical medical equipment or anything else like that. So, okay, so I have a variety of things here that really this inverter wasn't meant to power, but just for the sake of testing, I'm going to go ahead and run this thing with some of these items here. I'm going to be using my light bulbs here. I've got 100 watts and another 10-watt light bulb here. I also have a couple of 12.5-watt LED light bulbs that are here and here. I have a space heater. This is a Honeywell baby space heater. It's 165 watts on low, 235 watts on high. I also have a drill here. I do have a fan here. Now this is, again, just for demonstration. Some of these items actually have AC motors in them. I already mentioned the problem with a modified sine wave and an AC motor, but it's just to demonstrate the noise that's going to be coming out of this fan and the heat that it's actually going to be generating. We're going to do a 100-watt load. Let me go ahead and get into wattage. We are at a baseline of about 1 watt. So let's go ahead and get our 100 watts going right now. And we are up to 98.2 watts approximately, 99 watts. Let's go ahead and add another 10 watts to that. So we are at 109 watts currently now, 110 watts approximately, it looks like. Inverter's having no problem running these. Let's go ahead and add another 12.5 watts to this. And it looks like we're up to about 128, looks like. 128 watts approximately. Add another 12.5 to this. And we are approaching 140 watts right now. Now again, this inverter is rated to 130 watts continuous. We are above that 130 watts continuous. The inverter is still running just fine. So what I'm going to do is I'm actually going to keep this, looks like it's settled down to about 135 watts. I'm going to go ahead and keep this load on here for 1 hour. I'm going to come back in an hour and I'm going to see if at about 135 watts this inverter is still running fine. Okay, so at 135 watts is where it's about settled. The inverter is still running. It's been approximately 1 hour since I started this test. 135 watts doesn't seem to have too much of an issue on this inverter. It's still running fine. It is pretty warm though. I can tell you that right now, that it's really warm. I'm going to go ahead and I'm going to switch over to having this small space heater running. This is 165 watts. So I'm on the low setting right now, 159 watts. Seems to be settling right there. So I'm going to do the same test. I'm going to run this for an hour at 150 watts. I'm going to see how long this space heater will actually run. It is extremely hot. I have a feeling that I am going to burn this up here pretty soon. Again, 150 watts. We will see if this thing will stay running for 1 hour at 150 watts, which is the peak. It just went off right there. Okay, so powering the inverter back on. I let it cool down for about 10 minutes. Powering the inverter back on, it seems to run just fine. So there does seem to be some sort of safety on the inside that when it's loaded down or gets too hot, but it did in fact turn off. So the space heater can't be run for very long. Looks like maybe about a minute and a half. That's at 150 watts. So it looks like you can get about a minute to a minute and a half out of this before the inverter stops outputting. So that's a good thing to know. Let's go ahead and turn on this fan so you can hear the sound or hum that comes out of this thing. Okay, you might be able to hear that. And this AC motor is definitely heating up pretty quickly here. But that sound, that humming sound, is actually the modified sine wave running through the AC motor. Does not make that sound when I have it plugged into the wall or a pure sine wave inverter. Let's go ahead and turn that off. And just for fun, got it. Trigger all the way down. The kilowatt meter is actually running or showing 0 right now. I'm completely overloading the inverter. But surprisingly, the inverter has not become damaged in any way. It is still running just fine. So I'm actually pretty surprised there. Alright, so what can we take away from these couple of tests that I did here? Well, the inverter seems to run really strong up to about 140 watts or so, 135, 140. It's able to run continuously for about an hour at that point. Now, when I loaded it down to just a tad over 150 watts, right around 151, 152, you could see actually on camera live, the inverter actually shut down. I had to power off the inverter, turn it back on, and it's running just fine. Now, there is an internal blade fuse. I believe it is a 15 amp blade fuse on the inside of the inverter. I actually expected that fuse would actually break, but it didn't after all these tests. And I pushed this thing way beyond its limits. Alright, so where does that leave us overall with this inverter? How would I rate it? For design, this definitely gets 5 out of 5 stars. Looks is always a matter of personal taste, but the inverter does look pretty cool with its red and black design. Now, what about portability? Well, portability definitely gets 5 out of 5 stars. You can take this thing anywhere. It'll even fit in your pocket. It's just one of those things that was designed to be tossed in a cup holder or a bag and taken anywhere. It's very lightweight and you won't even know that you're carrying it. So how about reliability? Well, reliability definitely gets 5 out of 5 stars. Now, I say that because it does perform very well within its advertised limits. I didn't have any premature failures with this unit, and although I don't like the higher than normal voltage when it's not under load, for the most part, that voltage isn't going to affect any items, especially when you start to put it on a load. So what are my final thoughts on this inverter? Well, overall, this is a very good value. These things are pretty cheap. They do perform within the advertised limits. I do like the design. I like the fact that I was able to push it beyond its limits and it never did blow up. And just by turning it off and then turning it back on, it still runs. So you shouldn't have to worry about actually burning it up prematurely. Now, I didn't do an extended test beyond its limits, beyond 1 hour that is. But the unit still works fine after an hour of being loaded down to well over 200 watts. So yes, there are a few shortcomings with this particular inverter, but for the money, this is a great inverter and I highly recommend it. It is definitely a good product. So there you have it, folks. I think this thing performed really well, definitely within its advertised limits, and actually a little bit further than that. So it's a nice little inverter, and I think you'll be happy with your purchase. Of course, if you have any questions about this particular inverter, you can drop a comment down below, and I'll be happy to answer those. You can head over to my Facebook page at GP Vlogs, where I'll have more pictures, more test notes, and other thoughts on this particular inverter. And of course, subscribe to my YouTube channel, where you'll be able to see more reviews of not only this inverter, but many more PowerJack inverters. So thanks for joining me, and take care.